Very good morning to everyone.
Good morning, sir.
So we have discussed linear motion and velocity time graphs. I told you to visit Understanding Mechanics and try out some numbers. I don't know whether you visited. Before I get started, do I have any challenge that you landed on? Do you have any challenge that you feel the teacher should handle? So if no challenge, then we can introduce what we call vertical motion. Under gravity. We have always been looking at what we call linear motion. And linear motion was looking at bodies moving horizontally on a given surface. And because we have always been seeing motion of bodies moving in a horizontal surface, now we want to see what if bodies are thrown vertically upwards. What if this piece is thrown up? How does it move? Okay. Yeah, so that's what you're going to look at. So in that case, when a body is moving upwards, when the body moves or is projected vertically upwards, we regard its acceleration as acceleration due to gravity. So therefore, A is equal to small g. And this small g is what we shall have as 9.8 meters per second squared. In O level, you have been calling it 10 meters per second squared because it is rounded off. But here at advanced level, we go for its exact value. And in physics, we go for more of its decimals scattered for. In regard, in physics, we shall say it has 2 decimal places, and the 2 decimal places will be giving it g as 9.81. So in math, small g is 9.8 meters per second squared. This is math. Then g is equal to 9.81 meters per second squared. This is in physics. So these are the 2 possibilities of the values of g that we need to have. Furthermore, acceleration due to gravity, by definition, this is the rate of change of velocity for a freely falling body under a constant force field, like the gravitational force field. So this is the basic definition we can have in words. We can now go to definitions which are mathematical. Now, when a body is thrown vertically upwards, this is what is going to happen. When we throw a body, and this body moves up, this body is going to be going in this sense. There is no body force pulling it, but the body itself has a weight mg which acts downwards. Now, if you realize those two items, they are going to be important in this sense. This one, let me give it a dotted line. The acceleration with which this body will be moving will be got from the resultant force because the motion is moving upwards. So 0 overcomes mg to give us the resultant force, which is mass times acceleration. And with this regard, we shall have a negative mg is equal to ma. When you divide off the m, this is the reason why acceleration is always a negative g whenever a body is moving upwards. So when bodies move up, g is negative. We don't just cram and say g is negative because the body is moving up against gravity. We should be able to give this mathematical illustration as to why it is negative. Then for case 2, when it is moving downwards, then it is the weight that overcomes the 0 to give us the resultant force. And with this, mg is equal to ma. When you divide by m, the acceleration is equal to a g meters per second squared, a positive. Therefore, acceleration is positive whenever the body is moving downwards. Whereas acceleration is negative whenever a body is moving upwards. So, with that regard, the equations of motion you have v is equal to u plus 80. Vs is equal to ut plus a half 80 squared. V squared is equal to u squared minus plus 2g plus 2a s. So if I consider a body that is moving upwards, V is going to be equal to u minus gt. Where there is a, you put g. S is equal to ut minus a half gt squared. But normally this is called h. The distance moved upwards. Then v squared is equal to u squared minus 2g h. Then for downward motion, v is going to be equal to u plus gt. S is going to be equal to ut plus a half gt squared. Then v squared is going to be equal to u squared plus 2g h. So these are the basic equations that we require to have in this section of vertical motion. under gravity. So one will know when the body was moving up, what equations do we use? When the body is moving down, what equation is expected to be used? Then there are other notes you need to take. Note, when a body reaches maximum height, the body reaches maximum height, final velocity is 0. So if final velocity is 0, V is equal to U minus GT. It's going to be 0. Therefore, time is going to be, GT is going to be equal to U. When you divide by G, we can get the time as U over G. This time is called time to reach maximum height. Okay. So whenever a body reaches maximum height, you can always find the time it takes to reach maximum height. Second, you can also get maximum height. Let's take that screenshot. You can also get maximum height as a result of having final velocity being equal to 0. So if final velocity is 0, you can also attain height maximum from V squared is equal to U squared minus 2GH. Final velocity we have said is 0. So 0 would be U squared minus 2GH. Because H is, small h is maximum, let's call it H max. Then 0 will be equal to U squared minus 2GH max. Therefore, 2GH max is equal to U squared. Divide by 2G, divide by 2G. Then H max is equal to U squared out of 2G. So in case you always want to find maximum height, this is the equation you can use if nothing else has been given. When a body is dropped through a height h, the velocity with which it hits the ground you are dropping an item, check this out. You are dropping this white piece. I'm assuming my hand is the ground. It comes from rest. So with what velocity will it hit the ground? That is what the idea is, and the definition is talking about. So first of all, it is coming from rest, so initial velocity is 0. It is going to attain a final velocity V you do not know. From V squared is equal to U squared plus 2GH. Why am I saying plus? Because it's coming down. Remember, we have seen whenever bodies are coming down, acceleration due to gravity is 0. Therefore, V squared is equal to 0 plus 2GH. So V alone will be the square root of 2GH. So this is the expression of final velocity with which bodies hit the ground. Okay. So, unless if there is a definition I've not talked about. The graphs of speed and velocity, in this case, here they're not talked much about. The syllabus is silent about it, but we have them in physics. So those who offer physics, we shall see those graphs and get to know how they look like. So we are ready for examples, unless if someone has a question on any of the definitions I've given. Or you haven't taken a screenshot, I take you back. But otherwise, the topic is over. We are left with numbers to handle. So a question, a body is projected vertically upwards with a velocity of 24 meters per second. Find 1, when its velocity will be 4.9 meters per second. 2, how long it takes to return to the point of projection. How long it takes to return to the point of projection. Then 3, at what times will it be? At what times will it be? 1.96 meters above the ground. So take a screenshot and we have the number. Okay, hope we have the screenshot already. Now, the particle has been projected vertically upwards. I sketch a model for that. It's been projected vertically upwards, then it goes, and perhaps it comes back to the ground. Now, the first question says, when is its velocity 4.9? It has been projected down here with an initial velocity u, which is 24. But when the body goes up, because it's going against gravity, the velocity goes on reducing until it reaches the maximum, which is 0. So at maximum velocity here, at the maximum height, the velocity is 0. So the velocity goes on reducing. So they're asking you, when is it, at how long does it take to reach here, where the velocity is 4.9? So velocity at this level is 4.9. So we have the initial velocity as 24. They're asking for the time. Acceleration is a negative g. From v is equal to u minus gt, shall have 4.9 is equal to 24 minus 9.8 times time. So 9.8 times time will give us 24 minus 4.9. Therefore, the time will be 24 minus 4.9 divided by 9.8. So with this, we can make t the subject and then compute and get the answer. So what is the value of t? 1 point. Approximately 2.
1.949.
1.949 for the small places. Ends there.
0.
Okay.
0.
Apart from degrees in paper 2 math, everything is 2 decimal places, unless I've told you to write 1 decimal place. Now the second part, I forgot to derive for you that definition. How long it takes to return to the point of projection. In this case, they're asking you for what we call time of flight. How is time of flight computed? Time of flight is when the particle is projected from the ground like this one. It goes and it comes back to the same level which was projected from. This is the level of projection. When the particle goes with initial velocity, it comes back down. But the value with which it left, in this case, the u is equal to the v with which it comes back. So whenever you have the same level, a horizontal line through the travel of vertical motion, the velocity there is the same. So the velocity here, on leaving is always the velocity here on coming back. What does that mean? It means the initial velocity u and the final velocity v on return to the same level, that v and u are always the what? The same. So if you have seen that v and u are always the same, I can derive for you an expression which shows you how to get that time. Now, since we have said when the body goes and comes back, note, let me write these definitions here. Vertical displacement is 0. Now look at my image, look at the image, look at me in the picture. My body is here, a white body. My body is leaving this palm. We are going to project it to go upwards and then come back, okay? You who are watching right now, if I throw it up and it comes back, you are in position to confirm that the body left and it came back. A person who will find it just lying here will think the particle never left. You know why? Because he will be seeing it at the same position. That is why we are saying its particle displacement is 0. Because on going, it takes a positive displacement. On coming back, it takes a negative displacement. Therefore, when you total up the 2 displacements, because they are the same, the net resultant displacement becomes 0. That is why I'm saying vertical displacement is 0. So if vertical displacement is 0, what is going to happen? It means, who can give me the equation of motion for vertical displacement? Let me see who is available. Shakira Birunji, give me the vertical displacement for a body that has been thrown vertically upwards. Shakira, give me the vertical displacement for a body that has been thrown vertically upwards. Shakira, are you there?
Yes.
Yes, give me the equation for displacement. Yes. Masa, give me the equation for vertical displacement.
S is equal to UT minus a half GT squared.
Lovely, thank you. S is equal to a half GT minus, S is equal to UT minus a half GT squared. Remember we said for vertical motion, we substitute A with a negative G. When a body is coming back down, we substitute A with a positive G. We have said this is 0. So if it is 0, factorize. When you factorize, what will you attain? You'll attain U a minus a half of G of 1T is equal to 0. This will confirm that actually T is either equal to 0 or U minus GT over 2 is 0. Why is this 0? This is 0 now when the particle has not yet left. If it has not yet left, it has not yet covered any time. So that's why I'm saying T is 0. When it leaves and it goes and it comes back, that time is accompanied or is accounted for in this second bracket. So when the particle leaves and comes back, T cannot be 0 because you've seen it leave and it has taken some time going and coming back. Therefore, U minus a half GT is actually 0. So with this reason, U is equal to a half GT. Now I make T the subject, I'll get 2U out of G. And this time is what we call the time of light. The time of light, which time of light? Is the time the particle takes to go and come back. Now, if you do not know that equation, you will have to substitute in this one directly. But if you know this formula, just go for what the question says. How long it takes to return to its point of projection. So it means that time, we normally call it capital T, is twice the initial velocity, which is 24 divided by 9.8. Therefore, capital T is going to be equal to 48 out of 9.8. And what answer do we have? We have 3 points. So approximately 3.9 because
4.8970.
what? 4 point? 4.89.
4.8970.
70. So to 4 decimal places, the time is 4.8970 seconds. They tell you to write around decimal place, then it's approximately 5 seconds. If you had used G as 10, sometimes they can command you and say, take G as 10. There you go by that. If the question says take G as 10. But if the question has not commanded you to do any of those things, then maintain that G is always 9.81. Then we have the third question. The third question says, the third question was saying, what will be, at what times will it be 19.6 meters above the ground? Let me wrap this part so that we have the entire solution on one page. So they have said at what times would it be 19.6 meters above the ground? So assume this is the ground. And this particle, this is where the 19.6 meters is. It goes then it comes back like this. This is 19 point what? 19.6 meters. So they're asking you, at what times? There is a time here T1, there is a time here T2. But even sometimes they ask you, how long will it take to be above this height? I'm going to go through all those relationships. So to start with, in that case, height h is 19.6. Initial velocity is still 24. The time we do not know. The acceleration is a negative g. So from s is equal to ut minus a half gt squared, we shall have 19.6 is equal to 24 times time minus a half times 9.8 times time squared. 19.6 is equal to 24t minus 4.9 t squared. Therefore, 4.9 t squared minus 24 plus 19.6 is 0. Last time I talked to people about how to use a calculator to do this, but if you do not know how to use a calculator, first you show us the method, which is bulldozer method. This is 2040, which is 24, which is a negative b, plus or minus under the root of b squared, which is 24 squared, minus 4 times 19.6 times 4.9 divided by 2 times 4.9. Those of us who don't know how the bulldozer looks like, it is x1 and 2 is negative b plus or minus root of b squared minus 4ac, all divided by 2a. Our b, this is our a, this is our b, this is our c. For those who have smart calculators, press mode until you reach equations. We all have calculators which are smart or which are purely scientific, and you do not know how to use them to compute the quadratic equations. Abiba, you are very late today. So people press the calcs. If you don't know, let me know and I can guide you. Guys, what answer do you get? You know, sometimes I can use my head very well. So when students over delay, I make my head work. Though on days which I fast, I don't want to overwork myself, but since you're delaying, T1 and 2 is going to be in 24 plus or minus root of 576 minus 4.9. 4.9 is the same as 19.6. 19.6 squared is approximately 20. It's close to 19.6 squared over 9.8. 19.6 squared and 24. When you compute, what you get? You get 24 plus or minus. Those are two answers. Those two answers. The first answer is going to be T 0.99. What? And the second one, T is going to be 3.98. People, you're quiet. I was asking, do you have smart calculators, FX 100 and above?
Yes, teacher.
Do you know how to use them to find quadratics?
Yes.
Hey, then press and give me the answers. Those who
The
don't
first
know be
value of T is 3.8623.
3.8623. Thank you. Another one?
1.036.
1.036 seconds. So the times when the body is at 19.6 meters, when the body is here, the first time is the short time. So this is 1.036. The longer time is the second time, which is 3.8623. Sometimes they ask you the time it spends above. Hear that question. Time above 19.6 meters. It will be T2 minus T1, which will be 3.8623 minus 1.036. And what answer do we get? I've brought it up because they can ask you, though it wasn't part of the question.
Two point eight two six three.
2.8263. Very good. So we can have that down. Screenshot that. There are some two numbers I've sent on the group, which I want us to handle. I don't want to waste much time writing. Lotula has just woken up and she's just arriving. So guys, here is the question one. You can take a screenshot. A ball is thrown vertical upwards with a speed of 42 meters per second. Find where it is after 5 seconds. Yeah. Perhaps it has been projected from here. So when time is 5 here, they want us to find the height when it is 5 seconds. Okay, so Shakira, what again? What is the equation for vertical displacement? Shakira Babirunji?
S is equal to UT minus the half GT squared.
Okay, thank you. Now we are being asked to find H. The initial velocity is 42. The time is 5. Of course, G is 9.8. It is constant. So we shall have 42 times 5 minus half times 9.8 times 25. 25 comes from 5 squared. This will give us H is equal to 42 times 5 is 210 minus 4.9 times 5. 9.8 times 5 is 49. 49 times 5 is 245. 245 divided by 2, the answer is 122.5. So this is going to be, this is times 25. So this will be 210 minus 122.5. Calculator confirm, am I right? I guess I am. When you subtract, what do you get? 22.5, the balance is 7.5. The answer is 87.5. Right?
Yes.
Okay. When you delay, I will answer myself. Okay. Then they have said furthermore, The distance has traveled, full stop. If it falls past the point of projection into a well 70 meters, find when it strikes the ground. There is a note we need to have here. When a particle falls below a level of projection, the height is negative. The height is negative. So if you look at this as our question, and this is where it was projected, and it went and then came back and it fell down this way in a well, which well they have told us is having a height of 70 meters. When the particle leaves and comes back up to this level of projection, we saw the displacement is 0. So the only height it's covering is the height below, but the height below is negative. So in that sense, this is what is going to happen. You will say from S is equal to UT minus half GT squared. The displacement is going to be a negative. Why? Because the particle has gone below the level of projection. Therefore, we shall have negative 70 is equal to 42. Find when they're asking for time, 42t minus 9.8 t squared over 2. When you divide this by 2, you get 4.9. Therefore, we shall realize a negative 70 is equal to 42t minus 4.9 t squared. Thus, 4.9 t squared minus 42t minus 70 is equal to 0. Who are experts in the calculator? If you're not an expert, use bulldozer, which is a negative 42 positive plus or minus under the root. 42 squared minus 4 times 70 times 4.9. But the 70 is negative, so this becomes a positive divided by 2 times 4.9. Press the calc and give us T1 and T2. So today we have done calculations on vertical motion. Next week I'll do proofs. You know, in mechanics math, we overgo into these details. That's why we take a lot of time doing a given concept. So we shall deal with the same numbers, but when they have proofs, not solutions. Answers? I need need to conclude on these answers because you might get a challenge of how to conclude which is the time they want. So in this last definition, there's a key point there that whenever a particle goes below the level of projection, height is negative, and the height is that very height below which it travels. Someone give me the answer. You are solving 4.9 t squared minus 42t minus 70 is 0.
The first one is 10.
Exactly.
Yes.
Okay, the second one.
Negative 1.4286.
That's why I wanted this. Now, the reason why I wanted to see both of these answers, time is never a negative in this situation. You cannot have negative time because it's a real time. You're seeing the stone being thrown, the practical is real. So it's possible, and if and only if the time is positive. So the answer becomes time is 10 seconds. The answer. Yeah, so I wanted you to see that conclusion. Okay, that is okay. Then you have that down by taking a screenshot. Guys, if you have seen Notu's apology for late coming, there's another person who came in late. In case you are failing to get the password right, in most cases you must have missed out a figure. You have to take a breath, calm down, and insert in that thing again. Or you can even first reclose the app, then reopen it freshly. So hope you have taken the screenshot because I want to go to the last number. Otherwise, I waited for most of you. We started around 4 people, 3 students with a teacher, 4 people. And please, like I always say, you have a lot of numbers ahead of you, a lot. Visit Understanding Mechanics, visit Humphrey, visit Bostock. All those books, I sent them on the WhatsApp group. Those who are not on the group, I told you, always inbox me and I'll add you to the group. Okay. So there is a next number here which I want us to look at. How have I enlarged it? How do I go back? As it resets, let us remove this part. So here is our number. It says a man on top of a tower of height 35 meters. This is the tower. It is 35 meters. Holds his arm over the side of the tower, and he throws a stone vertically upwards with a speed of 14 meters per second. So he throws the stone. He does this. And he throws it upwards. Find the height above the ground. The highest point reached by the stone. Okay, if this is the ground, the stone is being thrown here. It is going to go reach maximum height. Perhaps it will come back down. But firstly, it means you need to find this height. Which height is maximum what? Maximum height above the level of projection. We saw that maximum height can be got from v squared is equal to u squared minus 2g capital H. But at maximum height up here, final velocity is 0. So 0 is equal to u squared minus 2gh. I'm reviewing this for those who have come in late so that they can see how maximum height comes about. So this is the equation for maximum height. If you know it, you just substitute. Therefore, maximum height can be got from the initial velocity was 14 meters per second. So 14 squared over 2 times 9.8. Maximum height will be 196 over 19.6. And the answer will give me 1960 divided by 196. And the answer is 10 meters. But this 10 meters is not the answer. The question has said height above the ground. That 10 is above the tower. Yeah? So total height would be 35 plus 10, and the answer is 45 meters, which is the answer here. That was case 1. The second one, the speed with which the stone reaches the ground. Now, because we have seen the stone is coming from the tower, and it leaves here, and it goes and it comes back down. Yeah. First and foremost, we have seen it reaches maximum height, which is 10 above the level. The initial final velocity here is 0. If this particle starts leaving from the maximum height to come back down here, we shall look for the new final velocity we don't know. So the height it will cover S is going to be 10 plus 35, because this one was 35, which is going to be 45 as the height. The initial velocity is the V, which is 0. The final velocity is what we are looking for. from v squared prime is going to be equal to u squared plus 2gs. Why am I saying plus? I'm starting from maximum height. The particle is coming back down. I will have the final velocity squared is equal to the initial 0 plus 2 times 9.8 times 45. Finally, the v prime can be got from the square root of 2 times 9.8 times 45. Those of us who have just joined, we said that kind of velocity is got from the square root of 2gh. You estimate where the particle is coming from, then you get the square root of the 2 times the 9.8 times the height from where the particle is falling. So the particle is falling from maximum height, because at maximum height, final velocity was 0. So we are assuming its initial velocity there is 0. When you do that, the derivation arrives at that. So that's why we end up concluding that that is the equation for finding final velocity with which the particle lands on the ground whenever it's coming from rest in the sky. Can we have this done? What's the answer?
$29.6985.
9.6985 meters per second. And indeed, it was the answer given. The time that the stone was in air. Hey, I hadn't seen that last question. The time the stone was in air, you can use the other first condition, which I've just discussed before, which takes time of flight. But you can also use this one when the particle goes below the level of projection, height is negative. So you can say the height it covers, because when it has gone up and come back to this level, the displacement is 0. So the height it covers is negative 35 is equal to the initial velocity, which is 14t minus a half times 9.8 times t squared. So negative 35 is equal to 14t minus 4.9 t squared. 4.9 t squared minus 14t minus 35 is equal to 0. Can you find me T1 and T2 in this regard? Then we conclude the time.
4.4590. And negative 1.6019.
Of course, the negative is out, so this is the answer. Okay. Now the next number is a proof. I can't start proofs now. I've said we shall start proofs next week. So the whole of next week, we are doing proofs. So I'm going to send some questions, which are in terms of solutions like these ones, but I'll also send some proofs from Humphrey so that you can try them out. By the time we come next week, some of you have given them a shot. Okay. Unless if someone has a question, but otherwise our time is up. We need to stop here for today. And I will meet the physics guys in the afternoon.
When they say the time that the stone was in the air, is it supposed to be that assumed level of the ground? The time at that assumed level of the ground which the stone is supposed to land?
No. Are you seeing me in the you're seeing me in my video? Eh? Can you see me? Yes. Now, assuming this is the level we are projecting the particle, you see that? This is my stone. The stone is going to leave, go up, reach maximum, come back, bypass where it left, and it goes down. That is the total time it has taken in air. Have you understood?
Yes.
Yeah, that is that's why. Now it is the same. Is time enough? Okay, let me borrow some time. I want to show you something. Let me explain something. Very fast. If I borrow some time here. Now, if this is the same stone, the time it takes to reach maximum height, when you get it, the first time, call it T1. Okay? Then from maximum height to down, call it T what? Let us prove and see whether it's the same. Remember, maximum height is got from U over G. Do you remember? So T1 would be 14, was it 14? 14 out of 9.8. What answer is this? 1 point? 14 divided by 1.8, the answer is? Yeah?
1.4286.
Now, the second time, initial velocity is 0 because you're coming. Because when a particle goes to maximum height, it stops, then it drops. So whenever they go up there, they come from a 0 velocity. So, but down here, we had seen its final velocity was what? Was 29.6985. Okay? So from V is equal to U plus GT. You will see that 29.6985 is equal to 0, the initial velocity, plus 9.8 for T2. Can you get T2? 29.6985 divided by 9.8. What answer do you get for T2?
.0305.
So the total time is supposed to be T1 plus T2. Confirm and see whether we get the same answer. What do you get? 4 point?
4.4590.
It's the same answer. Is it okay now? But the other one is shorter, eh? For the negative height, eh? Below the ground, below the level of projection. So this one is longer in a way that you compute 2 times, then you add them. Time of reaching maximum height, then time from maximum height to the ground. Okay. With that, I hope no more questions, because my time is up and I have to go to the senior 6 class. Okay, with that, take the screenshot. Are you done with the screenshot? Okay, I can close. There are some people who never took the screenshots for the first notes. There you go. Then before that, we had those definitions. Also take a screenshot. Okay, so with that, we can call it a day. You will meet the work on the WhatsApp group.